Hello, Primary 7. This week we're going to be starting our new maths topic, which is shape. And we're going to first of all be thinking about the properties of 2D and 3D shape today and tomorrow. Today I'm going to be looking through with you this PowerPoint about 2D shape, and we'll be thinking about the mathematical terms that we would use to describe 2D shape. So our learning intention today is we are learning about the properties of 2D and 3D shape. Let's get started. So the properties of 2D shape are different kinds of language that we would use. And this is really important when we're describing shape. So for example, we have straight lines, we have curved lines, nice and simple. We have longer or shorter sides. We're thinking today about 2 dimensions, so these are flat shapes. Remember, we're not thinking about objects today. These would be things, shapes that we would be drawn on a piece of paper. And we might be thinking about things like lines of symmetry or vertices, or if it has a vertex. So a vertex is the singular of a corner of a 2D shape, and vertices are more than one. So some of the other things that we might think about are the different angles within our shape. So here we have some angles. Now we haven't covered angles this year, but I know that you will have done this in previous years within your learning. So reminding yourself of the different kinds of angles that we have. We have over here, let me see if I can get my pen. We have over here an obtuse angle. Now obtuse means that is greater than 90 degrees. But smaller than 180 degrees. In the middle, we have a right angle. For those of you who remember, that's a 90-degree angle. That means that that line is going straight up, directly vertical to that horizontal line. And then an acute angle is smaller than 90 degrees. Okay, so it's smaller than 90 degrees. There would be a, oh dear, that's a very wiggly line. Smaller than 90 degrees. Now we also have a perpendicular line. Now perpendicular line looks a lot like the right angle. So here we have a right angle here. And if we look down here, perpendicular line, actually is very similar. It means that that line is going straight up from that horizontal line. Parallel lines, well, they mean that they are in exactly the same distance from the top to the bottom. They have to be the same distance from one side here across than they do all the way down. That's what a parallel line is, just like a train track. Okay, moving on. We have some circles. Now we're going to be looking at properties of a circle specifically later this week. So we're just going to whiz through this one. So how many, let me see if I can. How many curved sides does a circle have? Well, it has one, yeah, one continuous line that runs all the way around from one point all the way around to the same point. How many vertices, how many corners on our shape? Well, there are no vertices on a circle. It's a smooth line, no angles that are connected by 2 separate lines. How many lines of symmetry? Well, there's actually infinite. Infinite means we can't count the amount of lines of symmetry within a circle. And any interior angles? Well, the interior angle of our circle is 360 degrees. Now remember, I'm going to be coming back to this later this week, so don't worry if you're not quite understanding what that means. And how many pairs of parallel lines? Well, there are none, because actually we have one smooth curved side. For a parallel line, we have to have a straight line. For parallel lines, we must have straight lines, not curved lines. Okay, moving on. So triangles are something that we will also be coming back to, but just this is a general reminder of the properties of a triangle. So how many straight sides? There are 3 straight sides in a triangle. How many vertices? We've got 1, 2, 3. How many lines of symmetry? So there are up to 3 lines of symmetry connecting the point. Just show you because that went around really quickly. The point all the way through the center of that to the middle of the opposite straight line. Okay, so we would have 3 lines of symmetry going from the corner or the point, whoops, to the middle of that opposite side, and then not quite. See, I need a ruler right now. Okay, how many interior angles? Well, we've got 3 interior angles. And what type of angles can you see in this shape? Well, if we're talking about the interior angles, we actually have 3 acute angles. If we were thinking about, just wondering what color to use, the exterior angles, so the angles outside of the shape, they would actually be reflex angles. How many parallel lines? No parallel lines in this one. Remember, the parallel lines have to be exactly the same at the top, measuring across to the bottom, measuring across. Okay, let's move on. Primary. So a square, nice and simple. I'm going to race through this one. How many straight sides? Well, we've got 4 straight sides, 4 equal lengths. How many vertices? 4. How many lines of symmetry? 4 lines of symmetry. How many interior angles? We've got 4. There's a theme, primary 7, right? What does each interior angle measure? Okay, so each interior angle measures 90 degrees. We're not specifically looking at angles today in terms of measuring angles, but identifying the type of angle, I would be very impressed with our task later today. Okay, so what type of angles can you see in the shape? It's always going to be a right angle in a square or in a rectangle, always a right angle. Okay, how many pairs of parallel lines? We've got 2 sets, 2 opposite sides of parallel lines. And how many perpendicular lines? We've got 4 sets of perpendicular lines. Remember, that's around the right angle and the horizontal axis. Okay, moving on. Now a trapezium. Here is an example of parallel lines. In fact, let's see, we'll do that bottom one first. So there's 1 set of parallel lines within this shape, and they happen to be here. I'm just underlining it, and here. So in the red, they are the parallel lines. Now, if we look at the purple, that is not a parallel line because actually the part at the top goes in compared to the part at the bottom. See, they're not actually looking like train tracks. They're looking a little bit more sloped, like the roof of a house. So that one is not a parallel line. Just be careful when you're identifying shapes later and whether you have parallel lines or not. Okay, just racing through these different things. Straight sides, 4. How many vertices? 4. They're the corners, remember. Lines of symmetry, just 1 through the middle. Interior angles, we've got 4. Types of angles, well, we've got 2 acute and 2 obtuse. Remember, obtuse is greater than 90 degrees. Acute is smaller than 90 degrees. Okay, rectangle similar to a square. How many sides? We've got 4, but we've got 2 long sides and 2 short sides on a rectangle. How many vertices? 4. How many lines of symmetry? Just 2. Interior angles, we've got 4 interior angles because there are 4 sets of corner. And what does each interior angle measure? Well, each is the same as a square. It's 90 degrees because we have perpendicular lines. Let's look at the bottom. So we've got 4 sets of perpendicular lines, which in the interior of that angle mean that they are 90 degrees. They measure 90 degrees. How many parallel lines? Well, we've got 2 sets. And how many angles have you got? You've got 4 right angles. Remember primary 7, if I'm racing through too quickly, you can pause the video, go back and listen to me again, okay? So a rhombus, looking like our diamond, a rhombus can look in slightly different shapes, but we have 4 straight sides. We're getting repetitive, primary 7, because I want you to get into the language when you're using this for the task today, which is to describe your own shapes that you've found, okay? How many vertices? 4 vertices. Lines of symmetry, 2 lines of symmetry. How many interior angles? 4 interior angles. How many pairs of interior angles? We've got 2 separate pairs, so those pairs will measure the same each pair. But see, the top pair, the yellow pair, will measure the same, and the dark blue pair will measure different. So each pair will measure different amounts of angle degrees. Okay. What type of angles can you see in this shape? Well, we've got 2 acute, so the yellow ones are acute, and the blue ones are obtuse. How many pairs of parallel lines? We've got 2 sets of parallel lines. Okay, racing through these now, primary 7, because I want you to get onto your task. We've got a regular pentagon. Now, anything with pent is 5 straight sides, 5 vertices, 5 lines of symmetry, 5 interior angles, 5 obtuse angles, and there are no pairs of parallel lines in a pentagon. A regular hexagon. Now, later this week, we're going to think about regular and irregular shapes. So thinking about a regular hexagon now, we've got 6 straight sides, 6 vertices, 6 lines of symmetry, 6 interior angles as a theme, and 6 obtuse angles. And we've got 3 pairs of parallel lines on our hexagon. Heptagon, we're going up by 1, so we're now at 7. 7 straight lines, 7 vertices, 7 lines of symmetry, 7 interior angles, 7 obtuse angles, and there are 0 pairs of parallel lines here. Okay, our octagon, again, we're going up by 1. We've got 8 straight sides, 8 vertices, 8 lines of symmetry, 8 interior angles, 8 obtuse angles, and 4 pairs of parallel lines. Nonagon, again, we're going up by 1, so we must be at 9 straight sides now, 9 vertices, 9 lines of symmetry, 9 interior angles, 9 obtuse angles, and 0 pairs of parallel lines on a nonagon. How many straight sides? What a decagon? We've gone up by 1 again. We're straight sides, so we're 10 vertices, 10 lines of symmetry, 10 interior angles, 10 obtuse angles, and 5 pairs of parallel lines. Now, some of you might have noticed with all of those shapes that we've just looked at, when we have an even amount of sides, so we've got 10, 8, 6, that means we do have parallel lines. If we have an uneven set of sides and therefore vertices and therefore angles, so like 9, 7, and 5, then there aren't any parallel lines. Okay, primary 7. So you have now been refreshed with your understanding on properties of 2D shape. Your task today is to go and find 6 to 10 different objects from around your house that represent 2D shape. Now I know that objects are 3D shapes, so don't worry. What I'd like you to do is find things that you think I can share properties of a 2D shape by showing part of it. So maybe you've got one side of it, or maybe you've got the other, depending on what shape you want to share. I am looking for different. So please don't share with me 10 squares. I don't want to see 10 squares. I want to see 6 to 10 different shapes. Now you may have to be really creative with where you're looking, but as long as you've explained in mathematical language and justified your photograph or your image, then I'm happy with that. Okay, so for example, I've got my post-it notebook here, and it is a square. I'm going to identify it. I'm going to say what its name is. It's a regular square. It's a regular shape, sorry. By being a square, it is regular, but definitely it's a regular object. It's a regular shape. I've got 4 corners, therefore I've got 4 vertices. I'm going to say I've got 4 interior angles and that they all measure 90 degrees. I have 4 sets of perpendicular lines, and that's the line which goes from one side to then a horizontal side. Okay, remember 90 degrees at a 90-degree angle. I've got 2 sets of parallel lines, one this way and one this way. And I've also got 4 sets of symmetry, 4 lines of symmetry. Now, if you can, it would be really nice for you to share with me where those lines of symmetry are, whether you can actually do a wee indication, or maybe even if you're doing drawings, instead of finding objects, if you can't find the right amount of objects around your house, then to do drawings is fine, and you can draw those lines of symmetry on. Okay, so I'd like you to go away now, primary 7, and I'd like to go and find some 2D shapes. But it's not just the photograph I'm going to be looking at and marking later. I'm going to be marking your sharing of language around lines, around angles, around shape identity. So making sure that you've shared what shape it is, the vertices, the sides, and whether there's any symmetry. I may have said that one already. Okay, so I will write a list. I'll make sure that it's very clear on the task. If you'd like to, there's an extension task, which is to work through some multiplication and division work with thinking about shape as well. Okay, and I'll see you again tomorrow for some 3D shapes.